Hello, and welcome to our channel for knowledge before you sleep. Let your body relax, find a comfortable position in your soft bed, and slowly close your eyes. Tonight, we won't speak of the daily worries of life. Instead, we will embark on a journey together into the void, where distant stars are telling their own grand stories. Have you ever wondered, in the infinite silence of the night, what is happening in places millions of light years away from us? The universe is not as still as we might think. It is a colossal stage where galaxies, islands of light, containing hundreds of billions of stars, are performing slow and majestic dances. Sometimes, these dances lead them close to one another, merging together in the most magnificent event nature has ever created, the collision of galaxies. Don't worry, this collision isn't a terrifying explosion that happens in the blink of an eye. It is a process that stretches over billions of years, as gentle and slow as a silent symphony. In this series, we will learn about the power of gravity, about the birth of new stars from cosmic dust, and about the future of our very own home, the Milky Way. Let your imagination soar beyond the atmosphere, beyond the solar system, to immerse yourself in the flow of time and space. Now, take a deep breath, exhale slowly, and let's begin the first chapter of our journey. Chapter 1. The Scale of the Universe and Unimaginable Distances. Hello, you're listening to our Bedtime Knowledge series. In this first chapter, we won't rush straight into fiery collisions. Instead, let your mind relax and join me on a quiet journey to feel the breathtaking vastness of space. To understand what happens when two galaxies meet, we must first comprehend just how immense our own home is. The universe is not merely a large space. It is something that transcends all limits of human imagination. Imagine you are standing in a vast grassy field on a dark night, completely isolated from city lights. As you look up, thousands of tiny, sparkling points of light appear, like diamonds scattered on a black velvet tapestry. Each of those points of light is mostly a star, just like our sun, and some are even thousands of times grander and more brilliant. However, this entire magnificent scene that the human eye can behold is just an incredibly tiny fraction, a very small corner in the enormous castle of light we call the Milky Way galaxy. To measure distances in the universe, we can't use units like meters or kilometers, because the numbers would become impossibly long and confusing. Instead, we use the measure of a light year. Imagine this. Light, the fastest thing in the entire universe, can travel a distance of nearly 300,000 kilometers in a single, fleeting second. To help you visualize this incredible speed, in that 1 second, light can circle our Earth about 7.5 times. And yet, to cross the entire width of the Milky Way galaxy, it would take light about 100,000 years. 100,000 years is an impossibly long time compared to a human lifespan, and that's just the size of our own home. If we were to leave the Milky Way and look even further out, we would encounter a region of empty space, a vast ocean of darkness separating us from other islands of light. The closest large galaxy to us is Andromeda. Although it's called our closest neighbor, Andromeda is about 2,500,000 light years away. If we were to convert this distance into the kilometers that we use every day, the number would be roughly 24 quadrillion kilometers. That is a number with 16 zeros after it. To better understand this remoteness, let's look at humanity's greatest achievements. NASA's Voyager 1 space probe, currently the farthest man-made object, is hurtling through space at a speed of about 17 kilometers per second. At that speed, if the probe were heading straight for Andromeda, it would take tens of billions of years just to reach the edge of that galaxy. In the deep space between galaxies, almost nothing exists. It is an almost absolute emptiness, where there is no air, no sound, and a cold that permeates every corner. Out there, you might only find a few hydrogen or helium atoms, so sparse they are almost unbelievable, drifting alone across distances of billions of kilometers. However, even in this emptiness and silence, an invisible and powerful force is silently at work. That force is gravity. Gravity never rests. It is like an invisible but incredibly durable rope, connecting every object with mass in the universe. It is this very gravity that keeps the stars orbiting the galactic center, keeps the planets orbiting their stars, and it is also the force that is quietly pulling the Milky Way and Andromeda galaxies closer to each other with every passing moment. There is a wondrous fact that few people realize. Although each galaxy contains hundreds of billions of stars, the distance between the stars within a galaxy is also incredibly vast. Imagine if we shrank the sun down to the size of a single, small grain of sand. Its nearest star would be about 20 miles away. This very sparseness is the key to explaining why, when two galaxies collide, the stars almost never actually crash into each other. They pass through one another gently, like ghosts. Only their gravitational forces interact powerfully, twisting and reshaping the entire form of both giant galaxies. Through the great lenses of the Hubble Space Telescope and the James Webb Space Telescope, humans have been able to observe galactic collisions happening in other distant corners of the universe. The images they capture are as beautiful and magical as a dream, with ribbons of light stretching for millions of kilometers, made from billions of stars being stretched by gravitational tidal forces. We see galaxies twisting into each other, their colors of gas and dust blending to create strange and wonderful new shapes. The universe is a grand stage, and we have front-row seats to one of creation's most spectacular performances. The collision of galaxies is not a destructive explosion that happens in an instant, like what we often see in action movies. Instead, it is an extremely slow evolutionary process, a transformation that lasts for billions of years to create something new, larger, and more brilliant. As you lie here, in the quiet of your room, try to feel the rhythm of the universe. Our Earth is spinning, our solar system is moving, and our entire Milky Way galaxy is also hurtling through space towards its fateful rendezvous with Andromeda. Everything is in motion, in a perfect and gentle order. The numbers, like millions of light years or quadrillions of kilometers, no longer feel overwhelming or frightening. Instead, they become a quiet backdrop, helping your mind detach from the noise of daily life. We have just journeyed through the basic concepts of scale and distance, seeing how small we are, but also how fortunate we are to be a part of this great cosmic flow. In the next part of our journey, we will no longer observe from afar. We will venture deep inside to learn what a galaxy is actually made of. What is the structure of these islands of light that allows them to hold billions of worlds within? The story of the galaxies has only just begun, and the rhythm of the universe will lead us even further into mysterious regions of space. Keep your breathing steady and your mind light. We will continue to discover the secrets of the islands of light in the next chapter. Chapter 2. What is a galaxy? The structure of the islands of light. Hello, we meet again among the stars. In the previous chapter, we were awestruck by the seemingly infinite distances that even light takes millions of years to cross. Tonight, let me guide you deep inside a galaxy to explore the wondrous structure of these entities, known as the islands of light in an ocean of darkness. Imagine a galaxy is like a vast, brilliant city, but instead of buildings and roads, it is built from billions of stars, enormous clouds of gas, and delicate streams of dust. Our galaxy, the Milky Way, is just one of billions of such cities drifting through the universe. Each galaxy's cheese is a self-contained system, bound together by a silent but powerful force, gravity. First, let's look at the heart of the galaxy. At the center of most large galaxies, including the Milky Way and Andromeda, is a region called the galactic nucleus. This is where the stars are most densely packed, forming a brilliant and warm sphere of light. And at the very center of that heart, hidden deep within the dazzling glow, lies a sleeping giant, a supermassive black hole. Don't be too alarmed. Though it may sound frightening, this black hole acts as a great anchor, keeping the billions of surrounding stars from drifting away aimlessly. It is like a silent conductor, directing the dance of the entire galaxy from within the shadows. From that brilliant center, spiral arms begin to reach out, curving gracefully like glowing ribbons of silk. These arms are where the young, vibrant stars are concentrated. Imagine them as rivers of blue light, swirling through the vast darkness of space. Within these spiral arms, we find the stellar nursery's immense clouds full of hydrogen and helium gas. Hydrogen gas is the most primordial and essential ingredient of the universe. Under the pressure of gravity, these hydrogen clouds gradually contract and heat up until a new star is ignited. Alongside hydrogen, helium gas also plays a crucial role in creating the balance and energy of the stars. In the silence of the dark night, millions of new stars are still silently taking shape within those gas clouds, like green shoots rising from Mother Earth. Besides stars and gas, the galaxy contains another vital but often overlooked component: cosmic dust. Don't think of this dust as the ordinary stuff in your room. Cosmic dust is made of tiny particles of chemical elements like carbon and silicon. These ribbons of dust drift between the stars, sometimes so dense they obscure the light from the galactic center, creating mysterious dark lanes against the brilliant, starry background. It is these tiny dust particles that, over billions of years, will gather to form solid, rocky planets, just like the Earth we stand on. Beyond the brilliant disk where stars live, the galaxy is also surrounded by a part called the galactic halo. This is a vast and more sparsely populated region, home to the most ancient star clusters in the universe. These clusters are like ancient witnesses to time, having existed since the galaxy was just a primordial gas cloud. They quietly observe the rise and fall of younger generations of stars within the galactic disk. But perhaps the most mysterious thing about a galaxy's structure is something we can never see with the naked eye or any telescope. Scientists call it dark matter. Imagine the galaxy is like a spiderweb glistening with night dew, and dark matter is the invisible thread that keeps the dewdrops, the stars, from falling. Dark matter makes up the majority of a galaxy's mass, creating a sturdy skeleton for normal matter to cling to. Without dark matter, galaxies would fly apart, and the stars would drift into the cold emptiness of space. Each galaxy has its own personality, expressed through its shape. There are graceful spiral galaxies like the Milky Way, and there are elliptical galaxies that look like smooth balls of light, containing mostly old stars. And then there are galaxies with peculiar shapes that follow no rules, often the result of past collisions or interactions. As you lie here, try to imagine yourself slowly flying away from Earth, past the solar system, and then looking back at the panoramic view of the Milky Way galaxy. You would see a giant disk of light rotating slowly and majestically, 100,000 light-years across, yet it all operates as a single, living entity. The combination of hydrogen, gas, helium, dust, and billions of stars has created an unparalleled wonder. The collision of two galaxies, therefore, is not just the meeting of two masses of matter. It is the merging of two colossal cities, where rivers of hydrogen gas will mix together, where the dark matter from both sides will interact and alter the entire original structure. It's like two different symphonies being played at the same time. At first, it might create chaotic sounds, but eventually, they will combine to form a more majestic, grand chorus. Let the image of these islands of light gently imprint itself on your mind. Feel the softness of the dust lanes, the brilliance of the stellar nurseries, and the steadfastness of the invisible dark matter skeleton. You are in an incredibly stable and nurturing system, where every atom that makes up your body originated in the hearts of those distant stars. In the next chapter, we will learn about the invisible force that has guided galaxies toward each other. We will talk about gravity, the thread of destiny, connecting distances of millions of light years. But first, let yourself be immersed in the quiet beauty of these islands of light, where the life and death of stars unfold like the steady breath of the universe. Understanding the structure of a galaxy is the key to understanding what will happen when these two cities begin to meet. Every detail, from the tiniest dust particles to the supermassive black hole, will play a crucial role in the grand play we are about to discover. Chapter 3: Gravity, the invisible thread connecting the galaxies. Now that your mind has become familiar with these brilliant islands of light floating in space, let me guide you deeper into another great mystery. It is a silent power, without shape or color, yet it is what shapes the entire appearance of this universe. Scientists call it gravity. If galaxies are like dancers on a colossal stage, then gravity is both the rhythm and the invisible thread of destiny, pulling them closer together, beginning an encounter that will last for billions of years. Imagine you are lying on a deep black velvet carpet, soft and stretched out to infinity. That carpet is space. When you place a heavy crystal ball on the carpet, its weight will cause the fabric to sink, creating a depression around it. If you place a smaller ball nearby, it will naturally roll toward the depression of the larger ball. Our universe operates in a similar way. Every object with mass, from a tiny speck of dust to a giant star, and even galaxies containing hundreds of billions of stars, causes space around them to dip, creating a pull that draws everything else toward it. In the silence of intergalactic space, gravity acts like a durable rope. Although the Andromeda galaxy is about 2,500,000 light-years away from us, a distance we know is absolutely immense. The power of gravity can still reach it. It never tires, never breaks. With each passing second, the Milky Way and Andromeda move a little closer to each other, drawn by the enormous mass of the other. Mass is the deciding factor in this rope's strength. The more stars, hydrogen, and helium a galaxy contains, the more intense its gravitational pull. Our Milky Way is a very heavy galaxy, but Andromeda is even heavier. This interaction doesn't just happen between the stars we see. There's a secret that scientists have discovered through meticulous observations. Galaxies are actually much heavier than their light suggests. That extra weight comes from dark matter. Imagine dark matter as a giant ghost, embracing each galaxy. We can't see it with our eyes, can't touch it, but its gravity is incredibly real. It is dark matter that creates deeper depressions in the carpet of space, making the gravitational pull between galaxies much stronger and longer-ranged than we ever imagined. Without the assistance of dark matter, the Milky Way and Andromeda might have drifted alone in the darkness forever, instead of heading toward each other in a destined encounter. However, gravity doesn't simply pull two objects to slam into each other in a straight line. The universe has a fondness for gentle curves. When two galaxies begin to feel each other's pull, they don't charge straight ahead like two cars in a head-on collision. Instead, they begin a slow, spiraling dance. The gravity of one galaxy will start to bend the trajectory of the other, causing them to both hurtle toward each other and orbit a common, invisible center point. Imagine two ice skaters holding hands and beginning to spin. At first, they are far apart, their arms outstretched, and the circle is wide and slow. But as they pull each other closer, their speed of rotation increases, creating an artistic spiral. That is exactly how gravity directs the galaxies. Over the next billions of years, the Milky Way and Andromeda will continue to perform such rotations, getting closer each time until their starry arms begin to touch. Gravity also has another magical ability, which is the power to stretch matter, a phenomenon scientists call tidal forces. Think about how the moon pulls on the Earth's oceans, creating the high and low tides each day. On a galactic scale, gravitational tidal forces are millions of times stronger. As Andromeda approaches, its gravity will begin to stretch the ribbons of stars at the outer edge of the Milky Way, transforming our perfect spiral shape into long, flowing ribbons winding through space. Stars that were once securely in their orbits will be lifted up and pulled toward the neighboring galaxy, creating fantastical tails of light, hundreds of thousands of light years long. Throughout this process, the hydrogen and helium gas in interstellar space is also molded by gravity. Giant gas clouds will be compressed, collide with each other, and begin to ignite, creating new generations of stars. Gravity, instead of destroying, acts like a skilled potter, both breaking the old structure and molding more brilliant new forms for the universe. From a human perspective, we might see gravity as terrifying, for it can disrupt an entire galaxy. But if we look at the bigger picture, it is this very force that prevents the universe from descending into chaos and emptiness. It is what connects every soul, every speck of dust, and every star into a unified whole. As you lie here, feel this gentle truth. The Earth's gravity is embracing you, keeping you safe on the ground. And that same gravity is also connecting you to the most distant stars in the sky. Every movement in space, from the spin of a small planet to the grand collision of galaxies, unfolds with a precise and gentle rhythm, guided by the hand of gravity. It is never in a hurry. An encounter between two galaxies can last for billions of years, enough time for millions of generations of stars to be born and die. The patience of the universe is the most wonderful balm for our minds. We now understand this invisible tether, how it pulls giants together in a slow dance. The preparations for the greatest encounter in our local history have been set. Gravity has done its part as a guide, and now the stage is set for the very first real interactions. In the next part, we will enter the phase where the two galaxies begin to truly feel each other at close range. This is when noticeable changes start to appear, when our night sky will never be the same again. The first signs of their interaction will gradually become clear, heralding a promising new chapter in space. Let your breath flow with the gentle gravity of the night, and we will continue to explore these wondrous transformations in the next chapter. Chapter 4. When two galaxies begin to feel each other. Having explored the invisible thread of gravity that connects all objects, let us now step into the beginning of a grand reunion. This is the moment when the solitude of the two galaxies ends, when they truly start to feel each other's presence, not just through calculated figures, but through tangible changes in their own structures. This event doesn't happen suddenly like a clap of thunder. It begins with a gentle breath of space, stretching across millions, then billions of years. Imagine you are standing on a distant planet at the outer edge of the Milky Way galaxy. For billions of years, your night sky has always been a familiar ribbon of stars, but gradually, a faint, hazy smudge of light in the distance, the Andromeda galaxy begins to grow larger. At first, it's just a small streak of light you might mistake for a cloud, but over time, as the distance closes, it is no longer just a smudge, but a massive, brilliant entity that takes up a large part of the sky. That is the first sign that the two galaxies have begun to enter each other's zone of influence. In reality, this encounter begins long before the stars meet. Each galaxy is surrounded by a vast region of space called a galactic halo. This is where extremely thin gases and dark matter reside. As the Milky Way and Andromeda draw near, these two halos will be the first parts to touch. Picture them as two delicate clouds of vapor slowly blending together. In this intergalactic space, hydrogen and helium atoms begin to be disturbed. They no longer drift freely, but are drawn into a new vortex, compressed and pulled along by the combined gravitational pull of both sides. As the two galaxies move even closer, the tidal forces we mentioned in the previous chapter will begin to show their distinct power. Andromeda's gravity starts to pull strongly on the stars at the outer edge of the Milky Way. These stars, which had been peacefully orbiting the galactic center, now feel a new, compelling pull from the other side. They start to be pulled from their traditional circular orbits. The beautiful spiral structures of both galaxies begin to distort. The once smooth, starry arms now look like ribbons tossed by the wind, twisting and stretching for hundreds of thousands of light years into space. This distortion creates a melancholic yet magnificent beauty. Scientists call this phenomenon tidal warping. If you were to look from the outside, you would see that the two galaxies no longer maintain their perfect disk shapes. They look like two creatures extending long tendrils of light toward each other, trying to touch amidst the vast darkness. These outstretched streams contain billions of stars and large gas clouds, forming an invisible bridge between the two islands of light. During this phase, the speed of the two galaxies also begins to increase. Currently, Andromeda is hurtling toward us at about 400,000 kilometers per hour. Just think about that number. 400,000 kilometers for every hour that passes. At this speed, an airplane could circle the Earth in less than 10 seconds. However, because the distance between the two galaxies is so immense, up to 2.5 million light-years, even at that incredible speed, the actual encounter is still about 4 billion years away. This feeling for each other also leads to profound changes within the gas clouds. As the two galaxies begin to interact, enormous clouds of hydrogen gas are squeezed together by the sudden increase in gravitational pressure. This compression is like squeezing a water-filled sponge. In the universe, when gas is compressed powerfully enough, its temperature rises and a wondrous process occurs. New stars begin to ignite. This is when the first brilliant stars of the collision are born, heralding the most prolific period of star birth a galaxy has ever experienced. For a hypothetical observer living on a planet within the Milky Way, the night sky at this time would become incredibly fantastical. No longer a serene Milky Way, the sky would be filled with the brilliant glows of newly formed star nurseries. Andromeda would appear so large that it would no longer be an object in the sky, but the sky itself. You would see the dark dust lanes of the neighboring galaxy obscuring parts of our own stars, creating a mesmerizing tapestry of light and shadow. Yet, in all of that grand upheaval, there is a strange stillness. Though the stellar streams are stretched and the gas clouds are compressed, space is still incredibly vast. The stars are still millions upon millions of kilometers apart. The collision at this stage is more like a long-distance conversation, using light and gravity rather than a physical impact. Everything happens slowly, majestically, in step with the rhythm of cosmic time. A human lifetime, or even the entire history of humanity, is but the blink of an eye compared to this process of two galaxies getting acquainted. As you lie here and let your mind drift with those stretching streams of stars, feel the immense patience of nature. There is no rush, no panic. Every shift follows the absolute precision of physical laws. Two giants are approaching each other in an arrangement set in motion billions of years ago. Gravity has led them by the hand to each other, and now they are beginning to feel the warmth and pull of the other. This feeling phase is a crucial prelude to what comes next. It is like the overture of a symphony, where the instruments begin to play their first notes, preparing for the explosive crescendos to come. The distortion of the spiral arms, the birth of new stars from hydrogen gas, and the changing night sky are all important milestones on the journey of merging. We will continue to follow this journey, as the two galaxies are no longer just observing each other from a distance, but begin to truly intertwine. In the next chapter, we will explore one of the strangest things about cosmic collisions. Why, among the billions of stars hurtling toward each other, direct collisions between them almost never happen. It is a mystery about the emptiness and vastness of space that we will decode together. Now, let your imagination gently land. Feel the firmness of the ground beneath your back and the surrounding stillness. The distant galaxies are still silently moving, and we are drifting along with them in the eternal river of time. Chapter 5. Why do stars almost never collide? In the vast silence of the universe, there is a paradox that leaves us in awe. When two galaxies, massive structures containing hundreds of billions of stars, plunge into one another, we often imagine a cataclysmic explosion, where planets and suns smash into each other like cars on a highway. The reality, however, unfolds in a much more ethereal and gentle way. Tonight, we will decode the mystery of the great emptiness within these islands of light, to understand why, in a grand collision, stars can pass through each other like ghosts. To understand this, we need to change our perception of a galaxy's density. When we look at photographs of the Milky Way or Andromeda from afar, we see them as brilliant and dense with light, like a thick fog bank. But that is merely an illusion of distance. If we could shrink ourselves down and stand inside a galaxy, we would see that space is, in fact, incredibly sparse. A model. Let's try a little comparison to help your imagination picture it. Suppose we shrink our sun, which is a giant sphere with a diameter of about 1,400,000 kilometers, down to the size of a tiny ping-pong ball. At that scale, our nearest star, Proxima Centauri, wouldn't be right next to it. It would be about 1,100 kilometers away from our ping-pong ball. Imagine one ball in this city and another ball in a city over 1,000 kilometers away, and between them, there is absolutely nothing but empty space. In a galaxy, the average distance between stars is about 4 to 5 light years. If you convert that to kilometers, the number would be around 38 trillion kilometers. To make it even easier to visualize, if each star were a flying pigeon, then each of those birds would have a space as vast as the entire continent of Asia to fly freely without ever meeting another one. It is because of this almost unbelievable sparseness that the probability of two stars actually smashing into each other during a galactic collision is nearly zero. Scientists have calculated that even when two galaxies containing hundreds of billions of stars merge, perhaps only a few pairs of stars would actually have a chance of a head-on encounter. The event of two galaxies passing through each other is like two large clouds of smoke drifting past one another in a quiet room. The smoke particles might mingle, but they rarely collide. Instead of explosions, the most powerful interaction here is the invisible arms of gravity. When a star from one galaxy flies past a star from the other, even though they are billions of kilometers apart, they still feel each other's pull. This gravitational force will alter their orbits. Imagine stars as pedestrians strolling leisurely across an incredibly vast plaza. When two groups of pedestrians walk through each other, they don't collide, but each person might lean slightly or alter their pace a bit out of curiosity or due to the pull of those passing by. The result is that after the encounter, no one gets hurt, but everyone is no longer walking on the same straight path as before. Many stars will be pushed into completely new and strange orbits, and some less fortunate stars might even be flung out of the galaxy, becoming lonely wanderers in the dark intergalactic space. Throughout this wondrous passage, the planets orbiting those stars, including our Earth, could, in theory, remain safe. Because the distance from a planet to its parent star is very small compared to the distance between stars, a solar system will typically move as a single, unified unit. The parent star's gravity is strong enough to hold its planets firmly, even when the entire system is being stretched or pushed by enormous external forces. However, While stars can pass through each other like ghosts, other components of the galaxy are not so gentle. The giant clouds of hydrogen and helium gas, which make up most of the galaxy's volume, are enormous, millions of times larger than stars. When two galaxies collide, these gas clouds will inevitably slam into each other. Imagine the stars are tiny grains of sand, and the gas clouds are enormous, floating silk ribbons. The grains of sand can slip through the gaps in the ribbons, but the ribbons themselves will get tangled, compressed, and violently churned up. It is the collision of these hydrogen and helium gas clouds that is the source of the greatest transformations. Pressure and temperature will rise dramatically, setting the stage for the brilliant astronomical phenomena we will explore in later chapters. But for the stars, this collision has a very serene quality. They simply change homes, change neighbors, and begin a new journey in a larger galactic structure. The tolerance of space is astonishing. It allows billions of massive objects to move at speeds of hundreds of thousands of kilometers per hour, while still maintaining peace for each individual body. This helps us realize that, though the universe may seem crowded with billions of galaxies, each star and each planetary system still has enough room to exist and evolve. As you lie here, take a deep breath and feel that gentle sparseness. You don't need to worry about chaotic collisions. The universe has arranged everything with incredible skill. The emptiness between the stars is not a fearsome loneliness, but a protective embrace, allowing life and worlds to endure amidst the most terrifying upheavals of creation. The stars will continue their journey of passing through, illuminating the night with a soft, steady light. They are like tiny oil lamps in a dark ocean night. No matter how large the waves, the distance between them is enough to keep any single lamp from extinguishing another's light. We've now understood why solid entities like stars can pass through each other so smoothly. But the story of the collision doesn't end there. If the stars are ghosts, then the clouds of gas and dust are passionate and vibrant characters. In the next part, we will move away from the lonely stars and turn to the greatest construction sites in the universe, where clouds of gas and dust are preparing to create a revolution of light. Let your mind continue to drift along with the stars as they move slowly in their new orbits. Feel the gentleness of space and the slow pulse of cosmic time. Everything is proceeding just as it should, calm and full of majesty. Chapter 6. Clouds of gas and dust. The raw materials of life. While the stars drift past each other like silent ghosts, there is another component of the galaxy that reacts with incredible energy and intensity when the collision begins. These are the giant clouds of gas and dust, entities that occupy most of the space between the stars, but are often overshadowed by the brilliance of suns. Tonight, we will take the time to understand these delicate ribbons, because they are the very soul and the origin of all life as we know it. Imagine that the space within a galaxy is not a complete vacuum. Between the stars lies an environment called the interstellar medium, which holds a treasure trove of precious materials. The main components of these clouds are hydrogen and helium gas. These are the two most ancient elements, born at the dawn of the universe. They drift like gentle wisps of smoke, stretching for hundreds of light years, enveloping planetary systems in a soft embrace. Besides these primordial gases, the galaxy also contains an abundance of cosmic dust. This dust isn't like the tiny specks on your bookshelf. They are minuscule solid particles, made from elements like carbon and silicon, sometimes coated with a thin layer of ice made from water or ammonia. These dust particles are much smaller than a human hair, but they play an immense role. They are like tiny seeds that sow the beginnings of life, containing the chemical elements necessary to form oceans, mountains, and even our own biological bodies. When the Milky Way and Andromeda galaxies begin their merging process, these clouds of gas and dust cannot pass through each other as easily as stars do. Due to their enormous size, the clouds from both sides will inevitably slam into each other. Imagine two large waves on the surface of a calm lake. When they meet, they don't just pass through, but create ripples, foam, and a powerful disturbance. In the universe, when two clouds of hydrogen gas collide, they create incredibly powerful shock waves. These shock waves travel through the gas, compressing it with enormous pressure. Imagine squeezing a soft cotton pillow tightly, causing the fibers to be pressed closely together. When the hydrogen gas is compressed, its density increases and its temperature begins to rise. This is the most magical moment of the collision, the awakening of matter. From sparse and cold clouds, the compression creates denser regions where gravity begins to take over, pulling everything toward the center. It is in these compressed regions that cosmic dust begins to play its part. The dust particles act as a shield, protecting the inner gas regions from the extreme heat of surrounding stars, allowing the gas molecules to calmly clump together. Here, we will find the presence of familiar compounds like methane, carbon dioxide, and even more complex organic molecules. They are like a giant chemical soup being heated over the flame of gravity, preparing for the birth of a new generation of worlds. The collision of gas clouds also releases a tremendous amount of energy in the form of heat and infrared light. Although the human eye cannot typically see these bands of light, modern telescopes can capture brilliant images showing that colliding galaxies are actually the busiest construction sites in the universe. Instead of destruction, the clash of gas and dust is like an interplay of colors, where the mysterious dark dust lanes of one galaxy blend with the bright halos of the other. Interestingly, it's thanks to this collision that the universe is recycled. Heavy elements like iron, oxygen, or gold, which were forged deep within old, dead stars, are now stirred up and scattered everywhere by shock waves. They mix with fresh hydrogen and helium gas to create a perfect blend. Without collisions like this, the precious ingredients for life might have remained forever trapped inside lonely stars. A galactic collision, therefore, is the universe's way of sowing the seeds of life across the vastness of space. As you lie here, try to take a deep breath. Every molecule of oxygen you're breathing, every drop of water in your body, was once part of those great clouds of gas and dust. They endured terrifying collisions and million-degree shock waves, eventually coming together to form our home, Earth. The peace you're feeling right now is the result of a persistent, billion-year-long sculpting process. The flow of gas and dust in a galactic collision is a rhythmic symphony. At times, it's intense as two clouds meet. At other times, it's serene as they slowly merge and settle. Tiny dust particles drift through the darkness, carrying the hope of new planets, new oceans, and perhaps even new life that will be born in the distant future. In the silence of the night, let your mind become a tiny speck of dust, drifting amidst the magical ribbons of hydrogen gas. You are not alone, for around you are trillions of other seeds performing a dance of creation. We are not just observing an astronomical event. We are witnessing how the universe nurtures itself. After being compressed, the gas clouds will not remain still. They are preparing for a more pivotal moment, an explosion of light and energy that will change the face of both galaxies forever. The pressure mounts, the temperature rises, and the first points of light begin to twinkle in the darkness of the dust clouds. This chapter closes with the image of gaseous ribbons intertwining, creating a scene that is both ethereal and full of life. The preparations are complete. The raw materials are ready. The shock waves have done their part. Now, it is time for the universe to light its grandest candles from the ashes of the collision. Chapter 7. The Starburst. When darkness ignites, when the colossal gas clouds from two galaxies slam into each other, the inherent silence of space is completely shattered. This isn't destruction, but a grand awakening. Under the immense pressure of the collision, a magnificent phenomenon that scientists call a starburst begins to unfold. This is the moment when the darkness of the dense dust lanes is pushed back by the light of billions of new suns, illuminating an entire region of space, millions of light years across. To picture this storm, let's look deep inside the clouds of hydrogen and helium gas. Under normal conditions, these gas atoms drift about leisurely, keeping a safe distance from one another. But when two galaxies merge, gravity and shock waves from the collision ruthlessly compress them. Imagine a giant press squeezing all the thin smoke into a tiny space. When the density of the hydrogen gas reaches a certain level, the gas cloud's own gravity begins to overcome thermal pressure, pulling everything inward to collapse toward a single point. At those focal points, the temperature begins to skyrocket. From a few hundred degrees below zero, the temperature rapidly climbs to thousands, then millions of degrees. When the temperature reaches its extreme threshold, hydrogen atoms begin to collide and fuse together to form helium, releasing an enormous amount of energy. That is the very moment a star is truly born. In a galactic collision, this process doesn't happen in isolation. It occurs simultaneously on a galactic scale, creating an explosion of light we can hardly imagine. Normally, a peaceful galaxy like our Milky Way only forms about 1 to 2 new stars in a year. But during a starburst caused by a collision, this number can soar to hundreds or even thousands of new stars each year. These are called starburst galaxies. The light from these billions of brilliant young stars pierces through the hazy dust, turning the colliding galaxy into one of the brightest objects in the universe, visible from billions of light years away. Most of the stars born in this storm are massive blue stars. They are incredibly hot and brilliant, emitting millions of times more energy than our Sun. However, because they live fast, their lifespans are also very short, lasting only a few million years instead of the billions of years of smaller stars. Their presence makes the collision zone shimmer with color, a mix of blues, pinks, and purples from the superheated gas. From a distance, these star-forming regions look like precious gems set upon ribbons of dust. However, something prevents us from admiring this beauty with the naked eye: cosmic dust. The carbon and silicon dust particles surrounding these stellar nurseries are often so dense that they absorb most visible light. To see through to what's happening inside, we must rely on modern infrared telescopes like the James Webb. Infrared light can penetrate the thickest dust clouds, allowing us to observe newborn stars stirring within their cocoons. Images from the James Webb Space Telescope reveal a surprisingly bustling scene. Cascades of gas being pulled into new stars, powerful jets of energy shooting from the poles of young stars, and the formation of material disks around them, where, in the distant future, new planets will begin to take shape from compounds like water, methane, and ammonia. This explosion of new stars also has a powerful feedback effect. When the massive blue stars end their short lives, they explode in great supernovae. These explosions release the heavy elements they synthesized in their cores, like iron and oxygen, into the surrounding space. At the same time, the shock waves from the explosions further compress nearby hydrogen clouds, triggering another wave of star formation. It's like a chain reaction of life, where the death of one star sows the seeds for the birth of hundreds more. However, this starburst doesn't last forever. The very act of forming so many stars in such a flurry consumes a massive amount of the gas reserves of both galaxies. Scientists estimate that a collision can burn through nearly all of a galaxy's stored hydrogen gas in just a few 100 million years, a very short time compared to their billion-year lifespans. After the storm passes, the newly merged galaxy will often enter a quiet state, dominated by old stars, where very few new stars can be born. During the most brilliant moment of the collision, the night sky of any nearby planet would be an unforgettable sight. Clusters of young stars would rise side by side, so bright they could banish the darkness of night. Glowing gas clouds would stretch like giant neon lights from one end of the sky to the other. This is the universe displaying its full creative power, proving that, from the chaos of a collision, the most wonderful things can sprout. Let your mind immerse itself in the brilliant blue light of those young stars. Imagine the warmth from billions of new suns spreading through the coldness of space. You are witnessing the most intense pulse of the cosmic heart. The birth of each star is an affirmation of continuity, of nature's ability to renew itself. The simplest hydrogen atoms, sculpted by the hands of gravity and collision pressure, have become torches that illuminate the night. This brilliant flow of energy will soon reshape the entire appearance of the two galaxies. The spiral arms we once knew may disappear, giving way to new, strange, and more fantastical structures. The light from the starburst is the tool the universe uses to paint new forms in the void. As you breathe slowly, feel the tranquility gradually returning after the descriptions of the explosion. Although on a grand scale it is a terrifying storm of energy, from a distance of millions of light years, it looks like a gentle and majestic dance of light. The new stars are beginning their long journeys, carrying light and warmth to every corner of the newly forming galaxy. This storm is just the beginning of the changes in shape. Gravity, after triggering the star formation, will continue to pull and twist the entire structure of the two galaxies, creating long, winding streams of matter that snake through space like the tails of mythical creatures. These fascinating shapes are the result of a tug-of-war between immense forces, and we will explore them together in the next part of our story. Chapter 8. The Tidal Tales. The warped shape of galaxies. After the brilliant flashes of the starburst begin to subside and become part of the night sky, we start to notice another profound change taking place. The collision didn't just ignite new stars. It was also a colossal artist's hand, molding and twisting the entire shape of the galaxies. The perfect spiral structures, which had been maintained for billions of years, are now stretched and bent into fantastical shapes. In the language of scientists, these long, drawn-out streams of matter are known by a very poetic name: tidal tails. To understand why these tails form, let your mind return to what happens on our Earth every day. Have you ever wondered why the sea level rises and falls in a regular rhythm? It's thanks to the pull of the moon. Even though the moon is very far away, its gravitational pull still affects the Earth. The part of the ocean closest to the moon is pulled more strongly, creating the bulge we call high tide. In the vast cosmos, the same thing happens when two galaxies approach each other, but on a scale that is millions of billions of times grander and more powerful. As the Andromeda galaxy draws near the Milky Way, the gravitational pull from its immense mass doesn't affect every part of our galaxy equally. The stars and gas clouds on the outer edge, on the side facing Andromeda, will feel a much stronger pull than the regions deeper inside. As a result, instead of rotating smoothly in their old orbits, billions of stars and streams of hydrogen gas begin to be lifted up and flung out of the galactic disk. Imagine a dancer spinning in a long silk dress. If a strong gust of wind blows by or a hand accidentally snags the hem, the silk will no longer cling to the body, but will float and billow in the air, forming soft curves. The tidal tails are that silk train. They can stretch for hundreds of thousands of light years, reaching far into the empty space between galaxies, creating a bridge of light connecting the two great islands. Inside these tails is a colorful mixture. We have old stars that have existed since the dawn of time, now ejected from their former home. We also have young stars, freshly born from the starburst, shining with a brilliant blue hue. And of course, there are streams of fine dust and gases like hydrogen, helium, water, and ammonia. These components blend together, creating the glittering ribbons that we can observe through the Hubble telescope. Tidal tails are not just lifeless streams of matter. They contain stories of being torn apart and transformed. As the gas clouds are stretched out within these tails, the pressure inside them can sometimes be great enough to trigger the formation of small star clusters. These are called tidal dwarf galaxies, tiny children born from the chaos of their parents. These small galaxies will begin a life of their own, drifting along the tail of light like small boats on a long river. However, the fates of the stars within these tails vary greatly. Some stars, after being pulled far away, will slowly fall back toward the center of the newly merging galaxy, as gravity's pull still lingers. But other stars are not so fortunate. They are pushed away at such a great velocity that they escape the gravitational pull of both galaxies, becoming lonely wanderers. They will drift forever in the deep darkness of intergalactic space, no longer belonging to any city of light. Alone in the void, they illuminate the darkest corners of the universe until their energy is exhausted. When you observe tidal tails in astronomical photos, you'll see they often have a sharply curved shape, like fishhooks or the horns of an animal. This is the result of the combination of the galaxy's original rotation and the direction of the collision. Each collision creates a unique set of tails. No two are alike. It's like a fingerprint of the cosmos, telling us about the history, mass, and manner in which the two galaxies met. Within these twisted structures, scientists have also found traces of many chemical compounds. Scattered streams of methane and carbon dioxide create a diverse chemical environment. Despite being thousands of billions of kilometers from the galactic center, the presence of these gases suggests that life, or at least its first building blocks, could exist anywhere, even in these distorted and stretched streams of matter. Looking at the tidal tails, we feel a sense of fragility, yet also immense power. The fragility comes from seeing these colossal structures stretch thin like spider silk. The power lies in how gravity can orchestrate billions of stars with an invisible rhythm. Every twist and turn happens slowly. If you could watch a collision from start to finish, you would see these tails extend and retract over hundreds of millions of years, like the slow breath of a giant. Our future night sky, when the Milky Way and Andromeda truly merge, will no longer be a flat river of stars. Instead, it will be adorned with brilliant ribbons of light stretching across the sky. You will see rivers of stars flowing back toward Andromeda, and in turn, streams of stars from our neighboring galaxy will weave into our sky. It will be a spectacle so magnificent that no words can describe it. A place where the boundary between two worlds will be completely erased. Let your imagination slowly drift along those tidal tails. Feel the smoothness of space as you glide past billions of stars changing their course. There are no painful collisions, only a transformation to adapt to a new reality. The universe is teaching us about flexibility, about how beauty can arise from disruption and change. Every star in that tail, whether it is returning home or hurtling out into the darkness, carries within it light and warmth. They are like glittering grains of sand on an endless beach. No matter where the waves carry them, they are still a part of the great ocean. The twisting of galaxies is proof that nothing is permanent, but every change leads to new, more wondrous forms. As you breathe steadily and relax your body, imagine you are a tiny star on that tidal tail. You don't need to worry about where you are going, because a gentle gravitational force will guide you. You are participating in one of nature's greatest reshaping processes, where islands of light are merging to form a new continent of light. But the collision doesn't stop with the outer streams of stars. Deep within the heart of each galaxy, where darkness reigns, even greater forces are beginning to awaken. As these two colossal entities merge, the gatekeepers at the center will not remain on the sidelines. In the next chapter, we will leave behind the soft, silken ribbons of stars to venture into the mysterious central region, where supermassive black holes are preparing for a historic encounter. Chapter 9. The Giants at the Center. Supermassive black holes. We have journeyed together to witness the soft ribbons of stars being twisted at the outer edges of the galaxies. Now, let your mind slowly drift back inward, passing through brilliant gas clouds and bustling star nurseries to approach the most mysterious heart of every island of light. There, at the center of the Milky Way and Andromeda, reign the great and powerful entities that scientists call supermassive black holes. In a grand collision, these giants don't just watch from afar. They are the final protagonists who will decide the fate and shape of the new galaxy. To imagine a supermassive black hole, try to forget the frightening images of a monster that devours everything. Instead, think of it as the universe's grandest and most stable anchor. At the center of our Milky Way galaxy, this black hole is named Sagittarius A star. It has a mass about 4 million times that of the Sun, yet all of that enormous mass is compressed into an unbelievably small space. It is this tremendous gravitational power that has allowed billions of stars to orbit the galactic center in an orderly fashion for billions of years. Meanwhile, on the other side, the Andromeda galaxy possesses an even more majestic giant. The supermassive black hole at the center of Andromeda is about 100 million times the mass of the Sun. Just think about that number. 100 million stars like our Sun would equal the weight of a single point in the middle of that galaxy. As the two galaxies begin to merge, these two anchors also begin a long journey to find each other. This process unfolds incredibly slowly and silently. When two galaxies merge, these black holes don't just rush straight into each other. Instead, they are drawn toward the shared center of the newly forming galaxy through a process scientists call dynamical friction. Imagine the giant black hole swimming through an ocean filled with stars and clouds of hydrogen and helium gas. As it moves, its gravitational pull draws these stars and gases closer, creating a wake of matter behind it. It's this wake that creates a slight drag, much like the water resisting you as you walk through the sea, gradually slowing the black hole's speed and pushing it deeper into the core. Throughout this journey of millions of years, the two black holes remain shrouded in dense layers of matter. Surrounding them are enormous accretion disks, where gases like hydrogen, helium, and carbon-rich dust are heated to millions of degrees. At close range, the black hole's gravity is so strong it can bend light itself, creating brilliant, ethereal halos like rings of fire in the darkness. Despite being called black holes, thanks to the superheated matter surrounding them, the heart of the galaxy is actually the brightest, most radiant place in the entire cosmic structure. When the two giants finally get close enough, they begin a death dance, or more accurately, a symphony of gravity. They start to orbit each other in an ever-tightening spiral. At this point, the distance between them might be only a few light years, a tiny gap on a galactic scale. This system is known as a binary black hole. Imagine two colossal masses, each millions of times that of the Sun, spinning furiously in space, churning up their entire surroundings like a great cosmic whirlpool. The presence of this binary black hole has a tremendous impact on its surroundings. They're like two giant egg beaters, flinging stray stars out of the central region and stirring up gas clouds. Hydrogen and helium atoms are caught in the vortex, accelerated to nearly the speed of light. During this process, some matter is devoured, but another portion is ejected in two opposite directions, forming enormous jets of energy that extend for thousands of light years into space. As they draw closer, the two black holes begin to shake the very fabric of space and time. They emit gravitational waves, ripples in the fabric of space-time, much like when you toss a stone into a calm lake. These waves carry away some of the system's energy, causing the black hole's orbit to shrink even faster. This is when the rhythm of the universe becomes most urgent. A billion-year wait is about to culminate in a single moment of union. Finally, when the distance between them is cosmically minuscule, the two black holes merge into one. An invisible but incredibly powerful blast of gravitational waves will sweep across the entire universe. In the aftermath of that moment, a new black hole, greater and more powerful than ever before, will be born at the center of the merged galaxy. This new giant will be the new master, tasked with stabilizing the entire system of stars that has just endured a horrific upheaval. The merger of supermassive black holes is more than just a physical event. It is also how the universe regulates the growth of galaxies. The energy released from this process can blow away the remaining hydrogen gas clouds from the center, preventing uncontrolled, excessive star formation. This helps the new galaxy reach a state of equilibrium and tranquility after the collisional storm. As you lie here, try to imagine the absolute silence inside the point of no return of these giants. There, time seems to stand still, and all the familiar laws of physics become meaningless. However, it is this dark and mysterious core that keeps trillions and trillions of kilometers of space around it, operating in rhythm. You can feel the stability from that enormous mass, a sense of security, like having a sturdy anchor in a vast ocean. The hearts of the Milky Way and Andromeda are silently calling to each other. We don't need to fear these giants, for they are too far away to touch our small lives, yet powerful enough to shape the future of an entire galaxy. Their encounter is a testament to the fact that even the darkest things can create the most brilliant and meaningful impacts on the existence of the universe. Let your breath sink with the slow rotation of the stars around the galactic center. Feel the gentle weight of gravity embracing everything. The giants at the center have completed their guiding mission for this phase, but when they awaken and devour matter during the collision, they will create a phenomenon far more magnificent, a light that can outshine billions of stars combined. In the next chapter, we will explore a galaxy's most brilliant moment, when its central black hole gets to eat its fill and shines. That's when we'll get to know quasars, the greatest lighthouses of deep space. But before we get to that dazzling light, let yourself sink deep into the mysterious silence of these supermassive black hearts, where all the secrets of time are kept. Everything is still proceeding perfectly. The two giants are still drawing closer, little by little, in a majestic dance that surpasses all limits of human imagination. And we, tiny beings, remain safely protected in the embrace of that great gravitational force. Chapter 10. Quasars. When black holes awaken and shine brightly in the infinite silence of space, we've explored the supermassive black hearts hidden at the center of galaxies. However, there is a moment during the Great Collision when that deep darkness will no longer be silent. Instead, it will awaken and transform into the most brilliant and powerful object in the entire universe. Scientists call this magnificent phenomenon a quasar, or quasi-stellar objects that emit enormous energy. Tonight, let your mind be illuminated by these great lighthouses as we explore the moment a supermassive black hole eats its fill and begins to shine brilliantly amid the void. Normally, the black holes at the center of galaxies are like hibernating giants. They are quiet because there isn't enough food around to sustain powerful activity. However, when two galaxies like the Milky Way and Andromeda collide, everything changes completely. The violent collision between spiral arms and gas clouds will create a terrible gravitational disturbance. Huge streams of hydrogen and helium gas, which were peacefully orbiting on the outskirts, are now twisted by gravity and funneled directly toward the center. Imagine a storm of matter pouring into a bottomless funnel. When this massive amount of hydrogen gas and cosmic dust is pulled toward the black hole, it doesn't fall straight in. Instead, due to its immense rotational velocity, it forms a structure called an accretion disk. This is a giant ring of matter, spinning furiously around the mouth of the black hole. Here, dust particles containing carbon and silicon collide with each other at nearly the speed of light. It is this tremendous friction that generates an unimaginable amount of heat. The hydrogen gas is heated to millions, even billions of degrees, causing it to glow brilliantly across every frequency, from radio waves to X-rays. A single quasar can radiate thousands of times more energy than all the hundreds of billions of stars in the Milky Way galaxy combined. Just think about that power. A tiny point at the center can outshine an entire giant city of stars. In that brilliant halo, the supermassive black hole doesn't just devour matter. When the accretion disk spins too fast and becomes too hot, some of the energy and matter that can't fall in gets pushed back out. Extremely strong magnetic fields at the center focus these streams of matter into two ultra-fast jets of energy, shooting straight out from the black hole's poles. These jets are filled with high-energy particles, extending for hundreds of thousands of light-years into space, piercing through even the clouds of methane and ammonia gas surrounding the galaxy. They are like two giant spears of light, piercing the cosmic night. Thanks to these quasar lighthouses, humans can observe galaxies that are billions of light-years away from us. When astronomers use the Hubble or James Webb telescopes to look into deep space, they are actually looking back into the past. The light from a quasar that we see today may have begun its journey before the Earth was even formed. Quasars are the most ancient witnesses, telling us about the chaotic era when early galaxies first began to collide and merge with one another. However, the brilliance of a quasar also carries an important mission for the galaxy's growth. The tremendous energy it radiates creates immense radiation pressure, blowing the remaining hydrogen gas clouds away from the central region. This process is called energy feedback. Although this might seem like a destructive act, it actually helps the galaxy avoid excessive star formation that would lead to resource depletion. It helps regulate the galaxy's biological rhythm, bringing the system back into balance after the tempestuous collision. Imagine you're watching the entire collision from a safe distance. Amidst the twisted bands of stars and curving tidal tails, the galactic center suddenly erupts in light, like a great sun. That light is so brilliant, it illuminates the darkest corners of space, lighting up ethereal clouds of water, gas, and dust. It is the most magnificent moment, when the heart of the galaxy asserts its presence before the entire universe. As powerful and intense as it is, a quasar also follows a natural life cycle. When its food source, hydrogen gas, gradually runs out from being consumed or blown away, the accretion disk will cool, and that brilliant light will slowly fade. The supermassive black hole will return to a dormant state, awaiting another collision in the distant future to reawaken. The presence of a quasar in a collision is just a brief phase, but it is the most magnificent highlight in the history of any galaxy. As you lie here, in the silence of the night, try to feel this incredible contrast. Somewhere far away, the most tremendous energies are being released, lighting up a vast region of space, trillions of kilometers wide. Yet here, your breath remains steady, and the ground beneath your back is still firm. The universe embraces both grand explosions and small moments of peace. The light of a quasar doesn't blind or frighten us. Instead, it brings a sense of connection. Every atom in our bodies, from the heavy elements in our bones to the water in our bloodstream, is connected to high-energy processes like these. We are products of a universe in constant motion, ceaselessly transforming from darkness to light and back again. Those great lighthouses are silently telling the story of galactic evolution. They show that from chaotic collisions, the most brilliant light can emerge. When our Milky Way galaxy meets Andromeda in a few billion years, our own heart will one day blaze just as brightly, a proud greeting sent to the most distant reaches of space. Now, Let the image of the brilliant ring of fire, of the accretion disk, and the majestic jets of energy slowly fade from your mind. In its place, feel warmth and tranquility. We have passed the halfway point of our collision journey, from unimaginable distances to the brilliant hearts of galaxies. The greatest mysteries have slowly been revealed, and now it's time for us to return to our own home to see how this encounter will directly affect us. In the next part, we will step away from the distant quasars to focus on the fateful rendezvous between our two most familiar neighbors. We will take a closer look at the timeline and what will happen when the Milky Way and Andromeda truly begin to merge. But first, let the brilliance of the quasar guide you into a state of absolute relaxation, where light and darkness blend together gently. Chapter 11, the fateful encounter between the Milky Way and Andromeda. Having journeyed through the grand concepts of black holes and brilliant quasar lighthouses, it's now time to return to our most immediate reality. Tonight, we won't speak of distant galaxies billions of light years away, but will focus on a love story of cosmic proportions between our home, the Milky Way, and its largest neighbor, the Andromeda Galaxy. This is an encounter that has been destined for billions of years by the immutable laws of gravity, an appointment that no force can prevent. In the vast universe, galaxies often gather in groups. Our home is in a small cluster that scientists call the local group. This group consists of more than 50 different galaxies, large and small, but all of them orbit two main giants, the Milky Way and Andromeda. Between these two giants, there is an invisible yet incredibly strong bond. Although we are currently about 2.5 million light-years apart, the tether of gravity is silently shortening that distance with every breath of time. Andromeda is an incredibly magnificent entity. It contains about 1 trillion stars, which is twice the number of stars in our Milky Way. If the Milky Way is a glorious kingdom of light, then Andromeda is an even more dazzling empire. Currently, Andromeda is hurtling toward us at a speed of about 110 kilometers per second. Just imagine, in the blink of an eye, Andromeda has moved closer to us by a distance equal to the length of a large city. However, because the distance between the two galaxies is so immense, this movement is imperceptible to the naked eye. If you look up at the night sky tonight, Andromeda is just a faint, hazy patch, smaller than the full moon. But according to precise measurements from the Hubble Space Telescope, scientists have confirmed a certain truth. We are not just drifting closer, we are on a direct collision course. This is not a casual flyby, but a full-on merger. This encounter is predicted to truly begin in about 4.5 billion years. That's such a long time that even our sun will undergo major changes before this event concludes. But the beauty of the story lies in the fact that we can already predict that future based on what we know about the mass and velocity of both. The gravitational pull from Andromeda's immense mass is overcoming the expansion of the universe within our local group. As these two giants draw nearer, Earth's night sky will begin to change miraculously. In about 2 billion years, Andromeda will no longer be a faint smudge. It will grow larger and brighter than any star in the sky. Future generations, if they still exist, will witness an unprecedented spectacle. Two giant galaxies stretching across the sky, shining so brightly they could illuminate the ground on moonless nights. Andromeda is also filled with treasures of matter, just like our home. There are vast ribbons of hydrogen and helium gas ready for great starbursts when the two sides meet. Cosmic dust lanes containing carbon and compounds like methane or ammonia will blend together. This is not just a collision of stars, but the mixing of two enormous reservoirs of raw materials, promising to create entirely new generations of planets and worlds. Interestingly, there is a third important member in the local group, the Triangulum Galaxy, also known as M33. Scientists predict that Triangulum may be swept up in this dance and become part of the new giant galaxy after the Milky Way and Andromeda merge. It's like a marriage where the closest friends also come to live under the same roof. Although it's called a collision, we already know that the stars themselves won't collide. This collision is more like two ghosts passing through each other. However, gravity will violently disturb the structure of both. The graceful spiral arms of the Milky Way will be twisted and stretched into enormous tidal tails reaching toward Andromeda, and vice versa. Stars will be thrown into new orbits, creating an artistic chaos in the sky. As you lie here and contemplate this fateful encounter, feel our deep connection to the universe. We do not live in a static, isolated system. We are part of a grand, dynamic process. With every passing second, we are moving closer to our friend Andromeda. It is a long, long journey, carrying with it the hope of rebirth and growth. The merger between the Milky Way and Andromeda will ultimately create a new giant galaxy, often playfully called Milkomeda by scientists. It will no longer be a spiral galaxy, but will likely become a giant elliptical galaxy, a smooth, warm sphere of light where trillions of stars coexist peacefully in a more stable structure than ever before. The flow of cosmic time is truly patient. 4.5 billion years is a number beyond all human experience, but it is just one chapter in the diary of space. This fateful collision reminds us that change is inevitable, and within that change always lie the seeds of beauty and greatness. Let your mind drift at Andromeda's speed of 110 kilometers per second. Feel the gentle pull from the other side, a pull that doesn't cause pain, but only urges us forward. We are on a spaceship called Earth, hurtling through the darkness toward the most brilliant future a galaxy can have. Understanding this encounter helps us see our own place with more humility. We are just brief guests in a home that is preparing to be gloriously rebuilt. But it is this brevity that makes understanding these grand events so precious and meaningful. As we close this chapter, picture two bands of light gradually merging in the night sky, a perfect intersection of past and future. That fateful encounter is not an end, but a transformation to create a new, greater, and more encompassing entity. Now, let's prepare for a more detailed look at the timeline of this great collision. In the next chapter, we will go through each specific stage, from the first approaches until the two galaxies completely merge into one. Everything will unfold in a strict yet poetic chronological order, taking us deeper into the symphony of the cosmos. Chapter 12. The timeline of a billion-year collision. The universe operates on a completely different rhythm compared to our short human lives. While we measure time in seconds and minutes, great events like the collision between the Milky Way and Andromeda are measured in units of millions and billions of years. Tonight, we will step into an imaginary time machine to journey through the history of the future, witnessing each stage of transformation as the two galaxies gradually blend together in a symphony that spans millennia. Our journey begins in the present moment. Right now, the distance between the Milky Way and Andromeda is about 2,500,000 light-years. In the silent night sky, Andromeda appears as just a faint, hazy smudge, small and quiet. However, it is silently hurtling toward us at a speed of about 110 kilometers per second. Although this speed is very fast by human standards, the distance is so immense that we won't see any noticeable changes in our lifetime or even in the entire history of human civilization. Let's fast forward in time to about 2 billion years from now. At this point, gravity has significantly shortened the distance between the two neighbors. In Earth's night sky, Andromeda is no longer a faint smudge. It has grown larger and shines brilliantly, occupying a considerable portion of space. Its spiral shape begins to become clearer, with its dust lanes and clusters of young stars. This is the preparatory phase, when the two galaxies still retain their original shapes but have begun to feel each other's warmth through the first gravitational interactions in their surrounding dark matter halos. At the 3,750,000,000 year mark, the encounter begins to enter a dramatic phase. Andromeda now overwhelms the entire night sky, looking more brilliant and majestic than any part of the Milky Way we have ever seen. Gravitational tidal forces begin to display their immense power. The disk of the Milky Way galaxy, once flat and stable, starts to twist and warp. Its spiral arms are stretched out, creating strange new curves. This is when the streams of hydrogen and helium gas at the outer edges of the two galaxies begin to touch, preparing for grand chemical reactions. About 4 billion years from now, the moment of the first direct encounter will occur. This is when the two galaxies pass through each other. Remember, the stars almost never collide, but the gas clouds do. As the colossal streams of hydrogen gas slam into each other, the soaring pressure will trigger the most spectacular starburst in history. The night sky will explode with the light of billions of young, blue stars. Enormous tidal tails will stretch for hundreds of thousands of light years into space, carrying cosmic dust containing carbon dioxide, methane, and ammonia. Seen from a distance, the two galaxies will look like two mythical creatures entwined with each other in the vast darkness. After this first encounter, due to inertia, the two galaxies will temporarily pass through each other and begin to move apart again for a short while. However, they cannot escape each other's gravitational pull. They are like two ice skaters holding hands. After gliding past one another, they will be pulled back by an invisible force. Around 5 to 6 billion years from now, the Milky Way and Andromeda will return for their second and third encounters. Each time, their spiral structures will be destroyed even more dramatically. Stars will be flung into chaotic orbits, no longer lying on a single plane. Star nurseries, filled with water and complex organic compounds, will be disrupted and scattered everywhere. At this point, they are no longer separate galaxies, but have begun to melt into each other, forming a brilliant mess of light and matter. By the 7 billion year mark, the final merger process will come to an end. The two supermassive black holes at their centers will become one, releasing a final burst of gravitational waves that will shake the fabric of space. The chaos will subside, giving way to a new entity, the Milkomeda galaxy. This will be a giant, elliptical galaxy, a smooth, spherical, or egg-shaped structure where trillions of stars move in random but stable orbits around a single center. In this final stage, most of the free hydrogen and helium gas will have been consumed in the previous starbursts or blown away into deep space. The Milkomeda galaxy will then become quieter. It will no longer have magnificent spiral arms, but it will possess a serene and timeless beauty. Old red and yellow stars will dominate, emitting a warm and gentle light, illuminating a new empire of light established from the ashes of two old worlds. This timeline teaches us a lesson about patience and transformation. Everything in the universe has a beginning, a turbulent period of growth, and finally, a new state of equilibrium. 7 billion years is an unimaginably long time for us, but for the universe, it is just a slow breath in the constant evolution of matter. As you lie here, try to feel the stillness of the present. We are standing at the starting line of this grand timeline. The stars you see in the night sky tonight are still in their familiar places, but within each point of light is a part of the billion-year journey to come. The stability we have now is a precious gift, a moment of peace before the symphony of gravity begins to play its first notes. Let your imagination slowly withdraw from those billion-year figures. Return to the steady rhythm of your breath and the comfort of the present night. The timeline of the universe continues to flow, slowly and precisely, guiding us and our entire galaxy toward a predetermined destiny. What we have just explored is a panoramic view of change, where the end of one form is the beginning of another, greater entity. In the next part of our story, we will narrow our focus a bit, no longer looking at the galaxies as a whole. We will ask a more personal and important question. What will happen to our solar system and our Earth during this billion-year-long great collision? Can our tiny home survive the gravitational storms? We will find the answers together in the upcoming chapters of this journey. Chapter 13: The Fate of the Earth and the Solar System in the Great Collision. After having cast our gaze far out to observe the grand dance of billions of stars, tonight, let our minds gently return to our own familiar little corner. That is the solar system, home to a warm yellow star called the Sun, and a lush green planet named Earth, our home. In the midst of a cosmic collision of this magnitude, can a tiny planetary system like ours survive? Will Earth be crushed or flung into the lonely darkness? We will find the answers together in the stillness of this chapter. The first thing you can feel reassured about is that space is incredibly vast. As we know, the distances between stars are enormous, almost unbelievably so. The closest star to the Sun is about 40 trillion kilometers away. Because of this miraculous sparseness, the probability of a star from the Andromeda galaxy actually crashing into the Sun is nearly zero. Our solar system is like a tiny speck of dust floating in a vast, empty room. Even if another cloud of dust enters the room, it's very unlikely that two specific specks will ever meet. However, even without a direct collision, the solar system will still be affected by intense gravitational waves. Currently, the Sun and its planets are located about 26,000 light-years from the center of the Milky Way galaxy. As the two galaxies begin to merge, the gravitational pull from Andromeda will start to tug and push our position. Scientists have run simulations on modern computers and found a very interesting result. The Sun will most likely be pushed farther out from the center than it is now. Imagine you are on a small boat in a river. When a larger river flows into it, your boat won't sink, but it will be carried away by the new current, taking you to a different part of the river. During the collision, the Sun might be pushed to the outer edge of the new galaxy, about 100,000 light-years from the center. There is even a small chance that we will be temporarily ejected from the galactic disk and drift in the outer halo. But don't worry, wherever the Sun goes, our planets will remain tightly bound to their parent star. The reason is that the Sun's pull on planets like Earth, Mars, or Jupiter is incredibly strong at close range. The gravitational force from the entire galaxy can change the path of the whole solar system, but it is not strong enough to rip the planets from their orbits around the Sunday. Unless another star wanders too close to the solar system, an extremely low probability, the internal structure of our little home will remain miraculously intact. So, what would life on Earth be like during the billions of years this collision unfolds? If we could stand on the planet's surface and look up at the sky, we would witness the most spectacular light show in history. The night sky would no longer be a serene band of the Milky Way as it is now. Instead, it would be filled with the brilliant halos of newly formed stellar nurseries. Clouds of burning hydrogen and helium gas would create ethereal ribbons of pink and blue, stretching across the sky. Andromeda would appear enormous and distinct, revealing its winding dark dust lanes and billions of shimmering stars. However, there is an objective truth we need to address. The time of the collision's most intense phase, about 4 billion years from now, is also when our Sun will begin to enter the final stages of its life. The Sun will grow hotter and start to expand into a red giant. This means that, even without any galactic collision, Earth would become too hot to sustain its liquid water oceans and life as we know it. This temporal coincidence gives us a panoramic view of the universe's evolution. While galaxies are being reborn to form a larger entity, individual stars are also completing their own life cycles. The essential elements in our bodies, like carbon and nitrogen, and the gases in our atmosphere, like methane and carbon dioxide, all originated in the hearts of stars, and they will return to space to prepare for new beginnings. The most wonderful thing in this scenario is the peacefulness of the transition. Even as the entire galaxy is being twisted and warped, even as billions of stars are changing their course, here in the solar system, everything will continue to unfold according to precise physical laws. The planets will still orbit the sun steadily, and its light will still radiate, warming space. The universe protects the stability of its smallest structures, even while undergoing the grandest of revolutions. Try to close your eyes and imagine yourself floating in space, seeing the solar system as a tiny, sparkling gem amidst the colossal, luminous ribbons of two merging galaxies. We are not being abandoned. We are simply moving together to a new address in the depths of space. The collision does not bring destruction to our home, but rather a new perspective, a new sky, more brilliant and vast than before. Billions of years is an endlessly long time for life, if it still exists in some form, to adapt and find new homes. Perhaps future generations will no longer call Earth home, but they will always remember a small planetary system that resiliently weathered the gravitational storm to witness the birth of the great Milkomeda galaxy. As you breathe steadily in the silence of tonight, feel the stability of the Earth beneath your feet. No matter how much the universe changes, we are still protected in the sun's embrace and its gentle gravity. Everything is still proceeding in a harmonious and rhythmic way. You can rest assured that our small home holds a special place in the heart of the universe, and it will not be easily overcome by external changes. This collision is like a reminder that we are part of something much, much larger. We are not alone in the darkness. We are on a magnificent journey into the future with billions of other stellar companions. Every atom in your body has experienced upheavals like this in the past, and they will continue to exist through great collisions in the future. Let your mind relax completely. Our solar system is still drifting along peacefully. The planets are still performing their familiar dance against the starry backdrop. The collision of galaxies only makes the cosmic symphony grander and more colorful. We have just explored the fate of our home in the Great Collision. It is a story of resilience and the protection of nature. In the next chapter, we will expand our view once more to discover a mysterious component that acts as an invisible manager, directing this entire game. That component is dark matter. We will see how this invisible hand keeps the galaxies from flying apart during the collision process. Chapter 14. Dark Matter, the invisible hand that guides the game. Tonight, as all things have settled into silence and your breath has become steady, we will explore one of the greatest mysteries of the entire universe. We have spoken of brilliant stars, magical gas clouds, and powerful black holes. Yet, everything we can see with the naked eye, or with the most advanced telescopes, is actually an incredibly tiny fraction of the whole picture. Behind the mechanics of the great collision between the Milky Way and Andromeda is a silent caretaker, an invisible hand holding the destiny of billions of galaxies. Scientists call it dark matter. To visualize dark matter, imagine you are standing before a lake on a calm night. You see water lilies floating and starlight reflecting on the water's surface. Those water lilies and that light are the stars, planets, and gases like hydrogen and helium that we can see. However, the entire deep body of water beneath, the very thing that supports and determines the flow of those lilies, is completely transparent and invisible. Dark matter is that immense body of water. It is present everywhere, enveloping every corner of space, yet it does not emit light, reflect light, or absorb light. The existence of dark matter was discovered when astronomers noticed something strange. The stars on the outer edges of the Milky Way were moving much faster than calculations based on visible mass would suggest. According to the laws of physics, if there were only stars and clouds of hydrogen gas, the galaxy should have torn itself apart long ago, with stars flying off into the void. There had to be some incredibly massive gravitational force, about 5 or 6 times greater than that of ordinary matter, holding everything together. That invisible hand is dark matter, which makes up about 85% of the total mass of the universe. In the great collision between the Milky Way and Andromeda, dark matter plays the role of both the guide and the primary coordinator. Each galaxy is actually situated within a huge, diffuse sphere of dark matter, known as a dark matter halo. This halo is much larger than the stellar disk we can see. Therefore, long before the first stars of the two galaxies feel each other's presence, these two dark matter halos will have already begun to meet and merge. As these two dark matter halos intertwine, they create an effect that scientists call dynamical friction. Imagine trying to run through a deep lake. The resistance of the water would slow your steps. Dark matter acts as a kind of invisible superfluid, creating a gravitational drag on the approaching galaxies. It is this drag that saps the kinetic energy from the Milky Way and Andromeda, preventing them from simply gliding past each other and disappearing into deep space. Instead, dark matter forces them to turn back, spiral around each other, and finally, merge completely. Without the presence of dark matter, the collision might have been just a chance encounter and then a farewell. But thanks to this invisible hand, the universe can build grander and more stable structures. Dark matter is like a cosmic glue, keeping trillions of stars from being flung too far during the upheaval and helping to shape the structure of the new galaxy after the merger. There is a fascinating thing you should know about dark matter. Dark matter particles themselves don't seem to collide with each other in the way that normal matter particles do. When two dark matter halos meet, they pass smoothly through one another, like two gentle streams of gas, becoming one. They don't create hot shock waves like clouds of hydrogen or helium, nor do they cause brilliant explosions. Their interaction is purely through gravity, a subtle and silent language of the universe. Thanks to observations from modern instruments like the James Webb Space Telescope and data from NASA missions, scientists have been able to map dark matter by observing how it bends the light from distant galaxies behind it. This phenomenon is called gravitational lensing. It shows us that, even in the collision between the Milky Way and Andromeda, dark matter is always one step ahead, creating a sturdy skeleton for visible matter to cling to and grow upon. Within that invisible structure, dust particles containing carbon, molecules of methane and ammonia, and currents of water vapor continue to carry out their missions. Dark matter creates a stable environment, a gravitational well deep enough for the ingredients of life to gather and germinate. You can sense the generosity of dark matter. It occupies most of the space and holds tremendous power, yet it always steps back, ceding the brilliant stage to the shining stars and planets. As you lie here, try to feel the presence of this invisible arm. It's not just out there, among distant galaxies, but it could be passing through your room, through your body right now, without leaving a single trace. It is a part of the security that the universe provides for us. Thanks to dark matter, our galaxy has enough mass to keep the solar system from drifting aimlessly. Thanks to it, everything in the universe operates in a perfect order, instead of falling into a state of chaos. The collision of galaxies, therefore, is not just an event of light, but also an event of darkness, a constructive and protective kind of darkness. Dark matter ensures that from the ashes of two old worlds, a new, greater home will be built on the most solid foundation. It teaches us a lesson in humility. The most important, most powerful things are sometimes the ones we cannot see with the naked eye. Let your mind relax in the embrace of this invisible steward. Feel the stability of space, where every movement of the galaxies is calculated and coordinated by a silent force. You are protected by millions of trillions of kilometers of surrounding dark matter, keeping our world in a gentle embrace. The flow of dark matter during the collision is a slow, deep rhythm. It does not hurry. It waits for billions of years to complete its mission of connection. In the stillness of tonight, let the silent presence of dark matter soothe the anxieties in your heart. Everything in the universe, including the most mysterious things, is working to create a perfect balance. We have just explored the invisible arm that directs the game, a key factor for the collision to reach a happy ending. When the two dark matter halos have completely merged, all disturbances will begin to subside. That is also when the universe is ready for the final outcome of the merger journey, the formation of a giant and tranquil elliptical galaxy. In the next chapter, we will witness the moment the Milky Way and Andromeda are no longer two separate entities. We will learn about the shape, color, and soul of the new galaxy, a place where the chaos of the collision gives way to a timeless beauty. Chapter 15. The final outcome. The formation of the elliptical galaxy. After billions of years of intense turmoil, from the first tentative approaches to the brilliant starbursts and the tearing of tidal forces, the symphony of the collision finally reaches its most peaceful and stable notes. Tonight, we will witness the moment the Milky Way and Andromeda are no longer separate entities. They have melted into each other, merging every star, every gas cloud, and every mystery to create a single, great, and benevolent entity. Scientists call this final outcome the formation of a giant elliptical galaxy, a new continent of light in the ocean of space. This new galaxy is often called by the interesting portmanteau Milkomeda by astronomers. It is no longer a graceful spiral disk with delicate arms like the old Milky Way, nor does it have the characteristic winding dark dust lanes of Andromeda. Instead, Milkomeda has a completely different shape, a giant sphere or a smooth, egg-shaped form, glowing with a warm orange-yellow hue. This is the final evolutionary form of most major galaxy collisions in the universe. Why do the beautiful spiral arms disappear? Imagine you are watching a group of people dancing in an orderly circle. That is the state of a stable spiral galaxy. But when the collision occurs, the chaotic gravitational forces push and pull the dancers in all different directions. The stars, which were orbiting the galactic center on a flat plane, are now thrown high, dropped low, or have their orbits bent. When the merger is complete, the stars no longer move on a flat disk. They begin to move in random, interwoven orbits from all directions, like a swarm of bees flying around their hive. It is this chaotic yet stable motion that creates the puffed-up, three-dimensional shape of the elliptical galaxy. From a thin disk, our new home has become a full, sturdy mass of light, no longer having fragile structures vulnerable to external impacts. If you could observe Milkomeda from a great distance, you would see it has a very characteristic color, brick red or pale yellow. This marks a significant turning point in the galaxy's life cycle. As we know, the brilliant blue color usually comes from young, hot, and newborn stars. However, over the billions of years of collision, most of the fresh hydrogen and helium gas was either consumed in the intense starbursts or blown into deep space by the energy of quasars. With no more raw material to create new generations of stars, Milkomeda becomes an old galaxy in a positive sense. The giant blue stars ended their life cycles long ago, leaving only smaller, longer-lived stars like red and yellow dwarfs. They emit a gentle, enduring, and quiet light. This new galaxy is like a person who has passed through their vibrant, youthful years and is now enjoying the peace and tranquility of adulthood. Right at the center of Milkomeda, the two supermassive black holes have completely merged into one after performing their dance of death. This new black hole has a mass hundreds of millions of times that of the Sun, becoming the most stable anchor, keeping trillions of surrounding stars from ever drifting aimlessly. Around it, the dust lanes containing carbon dioxide and silicon dust particles have settled, creating a brilliant but peaceful core. There are no more violent jets of energy, no more blazing accretion disks. The heart of the galaxy is now truly at rest. The night sky of any planet within Milkomeda will also change completely. Instead of a delicate band of the Milky Way stretching across the sky, the entire sky will be flooded with the light of stars. No matter which direction you look, you will see dense specks of light, creating a night that is never truly dark. It is a sky of reunion, where stars from the two old worlds are now close neighbors. The interstellar medium inside Milkomeda is now very clean and clear. Most of the gases, like methane, ammonia, or clouds containing water, have been integrated into planetary systems or compressed into stars. The emptiness between the stars now has a perfect quality, where light can travel back and forth without much obstruction from hazy dust. This elliptical galaxy is an extremely stable structure. It can exist like this for the next tens of billions of years, without many major changes. Simulations from supercomputers at NASA and ESA have shown us that the formation of an elliptical galaxy is not a death, but a transformation. Milkomeda is a testament to the creative power of the universe. From two separate entities, through the pain of being torn apart and colliding, something greater and more benevolent was born. It shows that in the universe, chaos is only temporary, while balance and beauty are the ultimate goals. As you lie here, feel the absolute tranquility of this elliptical galaxy. Imagine yourself floating amidst that golden sphere of light. You will not see storms. You will not hear the roars of energy. There is only endless peace and a warm light embracing your mind. All the disturbances of the past have been put aside, making way for a stable and eternal reality. The formation of Milkomeda also reminds us of the law of conservation. Nothing is truly lost in this collision. Every atom of the Milky Way and Andromeda is still there. They have just been rearranged into a new and more perfect order. The stars still shine, the planets still orbit, and life in some form can still continue within the embrace of this giant elliptical galaxy. The symphony of gravity has reached its final, gentle, and deep rhythms. The galaxy, Milkomeda, now stands as a monument to time, the greatest island of light in the local group. It has fulfilled its mission of uniting what was always meant to be together. Let the image of that smooth sphere of light guide your mind into a state of deep relaxation. Feel the warmth from trillions of old suns, soothing the slumber of space. You are witnessing the fulfillment of creation, where all journeys find a peaceful harbor. We have gone through the entire formation process of the new galaxy, but to get a deeper understanding of how we know for sure these things will happen, in the next chapter, we will go back in time to look at the historical evidence. We will explore the past collisions that the Milky Way has experienced, to see that our home is, in fact, an experienced survivor of cosmic encounters. Chapter 16. Evidence of the Milky Way's past collisions model. We have just journeyed together to the end of the future, where the serene Milkomeda galaxy reigns in the void. However, to believe the forecast of the Great Collision with Andromeda, we need to travel back in time to look at the past of our own home. Tonight, let your mind settle and join me in tracing the ancient remnants left within the Milky Way. You will realize that our galaxy has not been a static entity since the dawn of time. It is an experienced survivor, a giant mosaic formed from countless collisions and mergers over the past 13 billion years. Imagine the Milky Way as a great journal, where each star is a line telling the story of its origin. Scientists act as cosmic archaeologists. They don't use shovels or brushes to dig through rock and soil, but rather superior telescopes to trace the passports of the stars. By measuring their speed, orbit, and chemical composition, they have discovered that many groups of stars within the Milky Way are actually immigrants from other galaxies that we have devoured in the past. The clearest evidence comes from the mission of the Gaia Space Telescope, an ambitious project by the ESA. This telescope has mapped the positions and movements of over 1 billion stars with astonishing precision. Thanks to data from Gaia, around the year 2018, scientists found a group of about 30,000 stars moving in very strange orbits, counter to the direction of most other stars in the galaxy. They are like a river flowing against the current of the ocean. This group of stars was named Gaia Enceladus, or playfully called the Sausage Galaxy, due to its strange shape on data charts. Gaia Enceladus was once a dwarf galaxy with about 1/4 the mass of the Milky Way at that time. About 10 billion years ago, it collided head-on with the Milky Way. This terrifying clash completely changed the face of our home, thickening the galactic disk and pushing many old stars into chaotic orbits. The stars from Gaia Enceladus are still weaving among us today, carrying a purer amount of hydrogen and helium, a living testament to a forced yet vibrant union in the distant past. But the Milky Way doesn't just stop there. If you look to the southern night sky, hidden behind thick dust clouds, there is another dwarf galaxy being torn apart by the Milky Way right now, the Sagittarius Dwarf Galaxy. For billions of years, this small galaxy has orbited the Milky Way like a satellite. But each time it passes by, our gravitational pull strips away a portion of its material. Today, Sagittarius looks like a long, drawn-out ribbon of stars, stretched thin and wrapped around the Milky Way several times. Its stars are slowly falling into our galactic disk, bringing with them dust containing heavy elements and compounds like water and ammonia. Scientists believe that these collisions with Sagittarius created gravitational ripples that triggered new waves of star formation in the Milky Way's disk. And perhaps one of those bursts led to the birth of our own sun about 4.6 billion years ago. How do we know for sure that those stars weren't born and bred in the Milky Way? The answer lies in their chemical composition. Stars born in the Milky Way typically contain more heavy elements like iron or carbon, as they inherit material from many previous generations of stars that have exploded. Meanwhile, stars from smaller dwarf galaxies are often poorer in these elements. By analyzing the light from a star, scientists can tell how much hydrogen, helium, and other metals it contains. This is the chemical fingerprint that helps us distinguish who the native residents are and who has come from afar. Besides individual stars, the Milky Way also preserves other fossils known as globular clusters. These are spherical collections of hundreds of thousands of ancient stars, densely packed with light and clinging to the outer halo of the galaxy. Many of these globular clusters are actually the cores of dwarf galaxies that have had their outer layers completely stripped away by the Milky Way. They are like pebbles left behind after a great torrent has washed away the soil and mud. Even now, as you prepare to drift off to sleep, two other neighbors, the Large Magellanic Cloud and the Small Magellanic Cloud, are also beginning their merger with the Milky Way. They are satellite galaxies that you can see with the naked eye if you are in the southern hemisphere. The Milky Way's gravity is pulling a massive stream of hydrogen gas from these two galaxies, forming a tail hundreds of thousands of light years long, called the Magellanic Stream. In the next few billion years, they too will dissolve and become part of the greater Milky Way family, enriching the supply of raw materials for future generations of suns. Looking back at past collisions helps us realize a gentle truth. A collision is not an end, but a process of nourishment. Each time it eats a smaller galaxy, the Milky Way becomes larger, more diverse, and more energetic. New stars born from the old ashes carry the necessary ingredients for life, from dust grains containing carbon to molecules of gases like methane or carbon dioxide. We, the humans living on Earth, may also carry within us atoms that once belonged to a distant galaxy that merged with the Milky Way billions of years ago. Let your mind relax in the flow of this grand history. Our Milky Way is a masterful artist, having collected pieces from all over space to create the brilliant form it has today. The scars from old collisions have now become glittering streams of stars, adorning the night sky with even more wonder. You are being protected within a galaxy that possesses the richest history and the most intense vitality. Feel the slow pulse of cosmic time, where even the most cataclysmic events unfold smoothly and majestically over millions of years. The Milky Way is still growing, still gathering and merging. This glorious past is the most authentic proof that the future rendezvous with Andromeda will be just a new chapter, grander and more brilliant. In our history book, in the next chapter, we will broaden our perspective even further, beyond the boundaries of the local group, to learn about galaxy clusters. This is where collisions are commonplace, where thousands of galaxies are crowded together, interacting in a never-ending dance. We will see that the collision of the Milky Way and Andromeda is actually just a small part of a great network of interactions throughout the entire universe. Chapter 17. Galaxy Clusters, where collisions are a regular occurrence. Throughout our journey so far, we have admired the beauty of individual islands of light and the fateful rendezvous between our two neighbors, the Milky Way and Andromeda. However, the universe is far vaster and more bustling than we can imagine on a local scale. Tonight, as darkness falls and your mind is ready for an even more distant flight, let me guide you away from our small local group and into the super metropolises of the universe. These are the galaxy clusters, places where collisions are no longer rare events that occur over billions of years, but a vibrant, powerful, and daily rhythm of life. If our local group is like a peaceful village with only a few large members, then galaxy clusters are the sleepless cities of enormous scale. A galaxy cluster can contain from hundreds to thousands of large and small galaxies, all held captive in an incredibly strong, shared, gravitational embrace. Here, the density of galaxies is so great that the distances between them become tighter than ever. It is this proximity that has turned galaxy clusters into relentless stages for the dance of collision and merger. One of our greatest neighbors is the Virgo galaxy cluster. Located about 54 million light-years away from us, Virgo is a colossal structure containing over 1,300 galaxies. When we look into the heart of this cosmic city through the Hubble telescope, we don't see tranquility. Instead, we see a complex network of interactions, where galaxies constantly glide past one another, stretching each other out, and sometimes devouring one another. The gravity here is so strong that it commands trillions of stars to move at speeds of up to thousands of kilometers per second. In this crowded environment, a fascinating phenomenon that scientists call galactic cannibalism frequently occurs. At the center of most large clusters, we often find a solitary giant, a supermassive elliptical galaxy. This giant is the result of continuously devouring smaller galaxies that stray into the core region. Over billions of years, it has accumulated mass from hundreds of collisions, becoming a great entity with a halo of light spanning millions of light years. This is the more complete future picture of the Milkomeda galaxy that we have mentioned before. However, galaxy clusters contain more than just stars and islands of light. There's another mysterious and scorching hot component that occupies most of the space between galaxies, known as the intracluster medium. Through X-ray telescopes like Chandra or XMM Newton, Scientists have discovered that the space between galaxies is actually filled with an incredibly hot gas, reaching tens of millions of degrees. The main components of this gas are still primordial elements like hydrogen and helium, mixed with traces of oxygen, carbon, and iron ejected from supernova explosions within the galaxies. This very same hot gas poses a major challenge for galaxies moving within the cluster. When a spiral galaxy plows through the dense intracluster medium at extremely high speeds, it experiences a tremendous drag force, similar to riding a motorcycle in a heavy downpour and feeling the pressure of wind and water hitting your face. Scientists call this ram pressure. This drag is so strong that it can strip away all the fresh hydrogen and helium gas from the galaxy, causing it to lose its ability to form stars and gradually become old. Imagine a beautiful galaxy hurtling through space, leaving behind a long, trailing tail, filled with glowing gas and new stars forming right within the stream of stripped material. This sight is both magnificent and melancholic, as it marks the permanent transformation of an island of light under the influence of its harsh, cosmic city environment. Dust grains containing carbon and molecules like methane or ammonia are also swept away, scattered into the shared space of the cluster, enriching the raw material for future evolutionary processes. Looking at galaxy clusters like Virgo or the distant Coma cluster, we realize that the collision of the Milky Way and Andromeda is just a small note in the grand cosmic symphony. In those distant places, trillions upon trillions of tons of matter are constantly being reshaped. Gravity acts as a tireless potter, shattering old structures to build even grander elliptical galaxies. Everything unfolds in a large-scale order, where the life and death of galaxies are harmoniously intertwined. Although galaxy clusters may seem turbulent, from a distance of millions of light years, they appear with a quiet and solemn beauty. The tiny specks of light gather like swarms of brilliant fireflies on a winter night. The frequent collisions here don't create a sense of chaos. Instead, they reveal the intense vitality of matter, always seeking to connect and merge to form more stable entities in the face of cosmic expansion. As you lie here, try to feel as though you are standing on a high mountain, looking down upon a valley full of moving cities of light. You no longer see the petty worries, but only a magnificent flow of time and energy. The colliding galaxies in a cluster are like drops of water merging into a river, all flowing toward a greater unity. The existence of clusters is proof that the universe favors community, where individuals find their meaning by becoming part of a grander structure. Every atom in your body, from the hydrogen in water to the carbon in your breath, may have once passed through such harsh environments before finding its way to our solar system. We are the products of these ceaseless collisions and mergers. Feel the warmth spread through you as you think about this infinite connection. You are not alone in the void, for you are supported by a gravitational web that stretches from the nearest stars to the most distant galaxy clusters. Now, let your heart beat slow to the majestic rhythm of the Virgo cluster's rotation. The islands of light are still silently performing their dance, illuminating the darkest regions of space. Their frequent collisions are the breath, the pulse that helps the universe constantly renew itself. And in that vastness, there is always a place for stillness and peace in your mind. Let the images of these brilliant star cities fade from your mind, replaced by a feeling of lightness and relaxation. We have journeyed through the most vibrant places, only to realize that movement is the very essence of existence. No matter where you are, beauty and order are always present, shaped by the masterful hand of nature. In the next part, we will return to a more profound issue: how these collisions and the energy from supermassive black holes feed back, preventing the proliferation of stars. We will learn about energetic feedback, a wondrous self-preservation mechanism galaxies use to keep from burning out too quickly. But first, let yourself sink deep into the absolute silence of the night, where every star is telling you a gentle lullaby. Chapter 18. Energetic Feedback. How Black Holes Halt Star Birth. In previous chapters, we've marveled at the splendid beauty of newborn stars, like fresh buds blooming in the winter night. However, in the universe, unchecked growth can sometimes lead to a swift decline. Tonight, as your breath becomes smooth and your mind drifts among clouds of gas, we will explore a miraculous self-preservation mechanism within galaxies. It's called energetic feedback, a way the central supermassive black hole regulates the pace of life, preventing excessive star birth to keep the galaxy in a state of eternal equilibrium. Imagine the galaxy is like an ancient house with a great fireplace at its very center. That fireplace is the supermassive black hole. During a major collision, the house is shaken, and a large amount of dry firewood, the hydrogen and helium gas, is dumped into the fireplace all at once. If the fire burns too intensely without control, the temperature inside the house would become too hot, incinerating everything and preventing anything new from growing. The black hole, with its power, acts as a wise steward, knowing when to stoke the flames and when to use that very heat to push excess fuel away. When the Milky Way and Andromeda galaxies merge, enormous torrents of hydrogen gas will pour toward the center. As we know, this awakens the black hole, turning it into a brilliant quasar. At this point, the black hole doesn't just swallow matter, it generates a tremendous outflow of energy, radiating back into the surrounding space in the form of thermal radiation and jets of material moving at nearly the speed of light. Scientists call this process feedback from an active galactic nucleus. This energy outflow has unparalleled power. As it sweeps through the clouds of hydrogen gas that are waiting to condense and form stars, it heats them to millions of degrees. You see, for a star to be born, the gas needs to be cold and dense enough to collapse under its own gravity. But under the hot breath of the black hole, the hydrogen atoms become too agitated. They fly about chaotically and can no longer clump together. This action by the black hole is like a strong gust of wind that dissipates the morning dew before it has a chance to settle on the leaves. The energy from the black hole not only heats the material, but actually blows it out of the galaxy. Enormous galactic winds carrying hydrogen, helium, and even dust particles containing carbon or silicon are ejected hundreds of thousands of light years away into the sparse galactic halo. Along with them, molecules like methane, ammonia, and even water vapor are swept up in this great exodus. This is a decisive eviction mechanism. By pushing away the raw materials for star formation, the black hole directly prevents the starburst from becoming too frantic. Why is halting this proliferation so important? If a galaxy uses up all its hydrogen gas in too short a time to create billions of young stars, it will quickly fall into a state of resource depletion. The massive young stars would die off very quickly, leaving behind an empty and cold galaxy. Thanks to energetic feedback, the black hole helps the galaxy save its fuel, reserving it for future generations of longer-lived, more stable stars. It keeps the galaxy's heart from beating too fast, giving life more time to form and evolve on small, rocky planets. This energetic feedback also has a profound impact on the shape of the Milkomeda galaxy we will one day inhabit. It helps to clear out the hazy dust, clouds, and excess gas in the central region, creating a clear and tranquil space. Through the James Webb Space Telescope, we can see vast voids inside colliding galaxies. These are the traces left behind after a black hole has just completed its regulatory task. Imagine you are floating at a safe distance, seeing brilliant blue and crimson streams of light extending from the galactic center like the arms of a protective deity. That energy flow may seem violent, but it carries a noble purpose of protection. It ensures that the new galaxy will not burn itself out in an instant, but will exist stably for tens of billions of years. In the outflow of ejected gas, traces of carbon dioxide and simple organic compounds are sometimes found. This suggests that the black hole not only pushes gas away, but also scatters the seeds of complex matter throughout intergalactic space. Energetic feedback, therefore, is also a way for a galaxy to share its chemical treasures with the vast expanse around it, enriching new lands that may form in the distant future. As you lie here, feel this magnificent regulation of nature. Our bodies have similar self-balancing mechanisms. Our heart rate, breath, and temperature are always kept stable to sustain life. So too is the galaxy. It is not just a lifeless mass of matter colliding. It is a sophisticated, self-regulating system that ensures its own long-term survival. The presence of a supermassive black hole and its feedback energy is a testament to the wisdom of the cosmos. The night has grown late, and the clamor of those energy flows now seems to be just gentle echoes in your mind. Everything has settled. The black hole has finished its work as a caretaker. The gas has been warmed and pushed into its proper place. The galaxy is entering a new state of equilibrium, where light and shadow, energy and matter blend together perfectly. You can feel a warmth spreading, like the gentle heat from a fireplace that has been dampened but is still warm enough to heat the room. This stability brings a sense of absolute security. There is no need to rush, nothing to fear from an excessive outburst. The universe always knows how to keep itself at peace. Let your imagination slowly drift along with those gentle galactic winds. Feel the serenity now that all the disturbances have been resolved. You are enveloped in a great system that always knows how to care for itself. This energetic feedback is not a prohibition, but an embrace, helping everything happen at the right time and in the right place. The rhythm of space is now incredibly slow. Old stars are emitting a soft, golden light, while thin clouds of hydrogen gas rest in the distant galactic halo, all awaiting for a more distant future, where collisions and mergers are no longer upheavals, but a part of eternal stillness. In the next chapter, we will move away from these internal mechanisms to look toward the most distant future of the universe. We will see what happens after all the collisions and mergers have been completed. What will the universe become when the last islands of light have found each other? But before stepping into that distant future, let yourself be immersed in the gentle equilibrium that the black hole has created for us. Chapter 19. The distant future of the universe after the mergers. The timeline of the universe continues to flow silently, like an endless river pouring into an ocean of stillness. After we have passed through the most tumultuous stages of the Great Collision between the Milky Way and Andromeda, it is now time for your mind to cast its gaze even further, beyond tens of billions, hundreds of billions of years into the future. Tonight, as darkness envelops you and your breath has completely synchronized with the silence of the night, we will witness the final portrait of deep space, a place where the islands of light have found each other, and the universe begins to enter an era of eternal peace. In the previous chapter, we saw the formation of the giant elliptical galaxy named Milkomeda. However, the journey does not end there. Our local group, with its more than 50 large and small members, will ultimately share the same fate. Under the relentless pull of gravity, satellite galaxies like Triangulum and the Magellanic Clouds will also be gradually drawn into the vortex and melt into the central galaxy. After a few tens of billions of years, instead of a group of separate galaxies, we will be left with only a single entity, a solitary and magnificent empire of light, reigning in the midst of a vast, empty region of space. Why does that region of space become empty? This is when another mysterious force makes its presence known: dark energy. While gravity tries to pull everything together on a small scale, dark energy is pushing distant galaxy clusters away from each other at an ever-increasing speed. As a result, in the distant future, neighboring galaxy clusters like Virgo will move so far away that their light can never reach us again. Imagine you are standing on an island in the middle of the ocean. At first, you can see the lights from other islands on the horizon, but as the water level rises and the islands drift further apart, those lights fade out until all that surrounds you is the dark black of the sea. Our Milkomeda galaxy will become such a lonely island. Future inhabitants of this galaxy, if they look up at the sky, will no longer see any other galaxies in the observable universe. The night sky will only consist of the stars belonging to their own galaxy, creating a sense of a small and tranquil universe, even though in reality, it is still expanding furiously on the outside. Inside that great island of Milkomeda, the pace of life also begins to slow down. The supply of fresh hydrogen and helium gas, the fuel for igniting stars, has now been depleted after billions of years of consumption. The bustling stellar nurseries of the past are now just distant memories. The new elliptical galaxy no longer creates many new stars. The brilliant, massive blue stars have long since faded, leaving the stage to the small red and yellow dwarf stars. These red dwarf stars are the most resilient inhabitants of the universe. They burn slowly, economically, and can exist for trillions of years. The light of the Milkomeda galaxy will now have a soft, reddish-orange hue, like an eternal twilight covering space. This is a somber beauty, where time seems to have lost its meaning. All disturbances from old collisions have completely subsided, giving way to a perfect and absolutely stable structure. Particles of dust, containing carbon and silicon, have now settled into cold planetary systems or been drawn into dense celestial bodies. Compounds like water, methane, and ammonia may still exist on rocky planets orbiting red dwarf stars, but they will be in a more tranquil state than ever before. The universe at this point is like an ancient library, where every book has been placed on the shelf, and there is no longer the noise of construction or destruction. Another wonderful thing that happens in this distant future is the housekeeping of gravity. Stray stars, streams of matter flung out during collisions billions of years ago, have now either fallen back into the central galaxy or drifted too far into the void. Interstellar space becomes incredibly clear. Light from old stars can travel through the galaxy without being obstructed by thick dust clouds. This clarity brings a sense of purity, where every point of light appears sharp and steadfast. From the perspective of a tiny being, this future may seem lonely, but it also contains great comfort. It is the comfort of an eternal home. After the ups and downs of a galaxy's life, after being twisted and torn apart, matter has finally found its most stable sanctuary. The merger of the entire local group creates a colossal community, where every star belongs to one large family, protected by a quiet, supermassive black hole at its center and a stable halo of dark matter surrounding it. Every atom in your body, the hydrogen atoms born from the Big Bang, the iron atoms forged in the hearts of supernovae, will all find their place in this great Milkomeda galaxy. We are not lost. We simply merge into a more enduring structure. The universe is teaching us about acceptance and harmony, that after all the battles and collisions, unity is the ultimate destination. As you slow your breathing in the peace of tonight, try to feel yourself drifting with the Milkomeda galaxy into that distant future. There are no more anxieties about terrifying collisions, no more disturbances from tidal gravitational forces. There is only you and the gentle light of red dwarf stars shining steadfastly through trillions of years. You are in a universe that is learning to rest after a long, arduous journey of creation. The symphony of the galaxies is reaching its final movements. where the instruments gradually fall silent, leaving only a somber yet majestic resonance of time. The islands of light have fulfilled their mission of connecting and nurturing. Now, they stand as witnesses to a heroic age, calmly facing the endless expansion of space. Let this stillness soothe your mind. The distant future of the universe is not a cold, terrifying darkness, but a well-deserved rest for matter. Everything has been arranged, every destiny fulfilled. You can fall asleep peacefully, knowing that even on the grandest scale of the cosmos, peace and order are always the final outcome of all turmoil. We have journeyed together through 19 chapters, from the first moments of sensing each other until all merged into one in eternal stillness. There is only one final chapter left for us to distill the meaning of this entire story. It is a time for us to look back on the collision not as a catastrophe, but as a new beginning for something even more wonderful. Now, allow yourself to feel completely light, completely at ease. Feel the vastness of space embracing you, just as the Milkomeda galaxy embraces its trillions of stars. Everything is unfolding perfectly in the flow of time. Chapter 20. The meaning of the collision. An end, or a new beginning. The grand cosmic symphony we have listened to together over the past 19 chapters is slowly reaching its final notes. Tonight, as your breath has become perfectly still, as your mind has drifted far from the worries of daily life to merge with the flow of the galaxies, we will pause for a moment to reflect on the true meaning of it all. The great collision between the Milky Way and Andromeda, an event spanning billions of years, is, in truth, a profound reminder of the nature of existence, that in the universe, nothing is ever truly lost. Every ending is merely preparation for a new beginning, one more brilliant and magnificent than before. We often tend to fear the word collision, as it brings to mind ruin and destruction. However, after having journeyed through each stage of this merger, you may realize a completely different truth. The collision of galaxies isn't a catastrophe, but rather a grand recycling process of nature. Imagine the universe as an artist kneading a giant block of clay. To create a new, more beautiful sculpture, the artist must break the old form, mix the materials together, and begin building anew from scratch. Throughout this journey, we have seen how the sparse clouds of hydrogen and helium gas, once lying solitary in the void, were compressed to burst forth as billions of new stars. We have seen how heavy elements like carbon, nitrogen, oxygen, and iron, forged deep in the hearts of stars, are now released and scattered everywhere to sow the seeds for new planetary systems. Without this collision, the Milky Way's supply of hydrogen gas might have quietly run out, and the galaxy would have slowly grown dark and cold. It is this encounter with Andromeda that brings a new lifeblood, a fresh source of energy for the universe to continue illuminating the night. Every atom that makes up your body, from the water in your bloodstream to the carbon in every cell, is actually a fragment from the collisions and explosions of stars from billions of years ago. We are not separate from this journey. We are a part of it. The collision of the Milky Way and Andromeda in the distant future will continue that same mission. It will mix the atoms of two worlds, creating new chemical combinations where molecules of methane, ammonia, and carbon dioxide will once again come together to build atmospheres for planets yet unknown. The formation of the giant elliptical galaxy, Milkomeda, which we have learned about, is a symbol of unity. After the gravitational upheavals and disturbances, after the tidal tails have settled and the quasars have fallen silent, what remains is a stable and serene structure. The universe teaches us that chaos is only a temporary phase, a necessary stepping stone to reach a higher state of equilibrium. Milkomeda is not just the end of two spiral galaxies. It is the birth of a great continent of light, where trillions of stars will coexist peacefully for tens of trillions of years to come. Faced with this immense scale, The small anxieties of human life seem to dissolve into nothingness. We realize that we live in an incredibly patient and vast system. The universe does not hurry. It takes billions of years to prepare for an encounter, millions of years to ignite a star, and an entire lifetime for us to look up and feel its beauty. The stillness of the night is the gift that space gives us, showing us that no matter how much the world changes, order and beauty always exist, orchestrated by the hand of nature. As you lie here, feel a sacred connection. You are not alone in the darkness. You are drifting with the Earth, with the solar system, and with the entire Milky Way galaxy on the path toward its fateful rendezvous with Andromeda. We are guests, participating in one of creation's most magnificent performances. The end of a familiar Milky Way is simply making way for a more brilliant night sky, where the light from trillions of suns will illuminate the path for new forms of life in the future. The cosmic symphony now leaves only the softest echoes. Gravity continues its silent work of connection. Dark matter still supports the entire structure of space in its invisible embrace, and the red dwarf stars continue to radiate a warm, steady light through the millennia. Everything is unfolding perfectly. There is nothing to fear, nothing to regret. The universe always knows how to renew itself, and we are the fortunate stardust who get to witness this miraculous process. Now, let all thoughts of numbers like billions of light years or millions of trillions of kilometers gently drift from your mind. Allow yourself to sink deep into the softness of your pillow, to feel the stability of the ground beneath you and the absolute stillness of the room. You are here, safe and peaceful, in the heart of the universe. The distant galaxies are still moving, the stars are still shining, and their grand future is still being written, slowly and surely. All mysteries have been unveiled, all journeys have found their way. It is time now for you to let your mind rest completely. Let your breath slow down, becoming steady, becoming light. Feel the warmth spreading from your heart throughout your body, like the soft golden light from the Milkomeda galaxy caressing space. You are a part of eternity, a part of the light, and a part of this endless peace. Our journey through 20 chapters on galactic collisions comes to an end here. I hope that this knowledge has brought you a new perspective on the beauty of the universe and helped your soul feel lighter. Now is the time to close your eyes, to let your imagination soar a little longer among the sparkling star fields, and then slowly sink into a deep sleep. I wish you beautiful dreams of islands of light, of the blending of space, and of our brilliant future in the heart of the vast cosmos. Sleep well,